Welcome to The Explainer. Today we're talking about LangChain. You've probably heard the name. It's the framework that is absolutely changing the game for anyone building with large language models. All right, so let's get right into it. Using an LLM seems easy, right? You make a simple API call, you get a response, but why is it so incredibly hard to build real, useful applications with them? It turns out there's a whole lot of complexity hiding just under the surface. And this right here really shows you what I mean. A simple API call, that's just a straight line. Input, LLM, output. Boom, done. But a real application, well, that's a whole different beast. It needs memory to remember what you talked about 5 minutes ago. It needs access to your custom data. It needs tools to actually do things. It's not a line, it's a loop, a smart, dynamic loop. And that brings us to what we could call the LLM developer's dilemma. See, the thing is, LLMs on their own are kinda limited. They're stateless, which is a fancy way of saying they have zero memory of past conversations. They have no clue about your private data, and they can't take any action in the real world. They're like a brilliant brain in a jar, totally disconnected. And that is exactly where LangChain steps in. Think of it as the ultimate toolkit for LLMs. It gives you all these modular building blocks, like Legos really, that let you connect that brain in a jar to other data sources, give it memory, and let it interact with its environment. All right, so let's break down how this actually works. We're talking about a framework of building blocks. So at its heart, LangChain has a few core components you really need to know. First, you've got your models. That's the interface to the LLM itself, like GPT-4o. Then you have prompts, which are basically your templates for talking to the model. Memory is a huge one. That's what gives your app the ability to remember past conversations. And finally, chains, which, well, they're the glue that ties everything together. Let's talk about prompts for a sec, because they're way more than just asking a question. A LangChain prompt is more like a structured template. It's a recipe you create to make sure your questions are always consistent and guide the model to give you the exact kind of reliable, relevant output you're looking for. And then there are chains. This is really where the magic happens. Chains are how you combine LLMs and prompts into multi-step workflows. I mean, the name says it all, right? You link operations together where the output of one step becomes the input for the very next one. It's super powerful. Okay, check out how a simple chain works. Let's say your first input is just one word, Rome. The first part of the chain takes that, sends it to the LLM, and gets back, say, a list of cool activities. Then, and this is the cool part, that list of activities automatically gets fed as the input into the next part of the chain, which then generates a full-blown, detailed itinerary. See? Super simple. Okay, so chains are cool, but what about data? How do we make our data conversational? This is where things get really, really interesting. Think about it. How can an LLM possibly answer questions about your company's private documents, or an article that was just published yesterday, or even the transcript of a YouTube video? The model wasn't trained on that stuff. Well, there's an answer, and it's a technique that has become a total game changer. It's called Retrieval Augmented Generation, or RAG for short, and the idea is brilliant. You're not changing the LLM or retraining it. You're just augmenting its knowledge with additional data that you retrieve on the fly. And here's the basic RAG pipeline. It's a 5-step dance, really. First, you load your documents. Then you split them into smaller chunks. You embed and store those chunks in a special database. Then, when a user asks a question, you retrieve the most relevant chunks, and finally, you generate an answer using both the question and those chunks as context. So that first step, loading documents, LangChain makes this easy. It can ingest data from literally hundreds of sources. We're talking PDFs, CSV files, websites, even YouTube transcripts. You name it, it can probably load it. Okay, once the data is in, it gets split up and then embedded. Now, embedding is just a fancy word for turning text into a list of numbers, a vector. But here's the key. These numbers capture the semantic meaning of the text. It's what allows the computer to understand that king is similar to queen in a way it's not similar to bicycle. And that brings us to the payoff. When you ask a question, the system finds the chunks of your data whose meaning is most similar to your question. It grabs that information, hands it to the LLM along with your original query, and says, here, use this context to answer the question. And out comes a precise, accurate answer. So, why does RAG matter so much? Well, it means you can give the LLM access to private or proprietary information. It can use data that was created long after its training was finished, and this dramatically improves accuracy and reduces those weird hallucinations we sometimes see. It can even cite its sources. It's how you get evidence-based, trustworthy answers.
All right, so RIG is incredible for answering questions, but what if we could go even further? What if an LLM could do more than just talk? What if it could act? This is where we get into the future, autonomous agents.
Yup, agents. The big idea here is to use LLMs to actually take actions. You give the language model a set of tools, and you let it figure out for itself which tool to use and when to get a job done. So what are these tools? Well, they're basically functions that an agent can call to interact with the world. A tool can be something simple like a search engine or a calculator, or it could be a super custom function that generates a financial report or books a meeting on your calendar. Anything, really.
And the way these agents often think is through a process called the react loop. It stands for reason and act. It's a cycle. First, the agent has a thought. It breaks down the problem. Then it acts. It chooses a tool and uses it. Then it observes the result. And based on that observation, it repeats the process, thinking and acting, until it finds the final answer.
Here's a super simple example of an agent in action. The query is, what is the square root of 101? The agent's first thought is, this is math. I should use the calculator tool. So it acts. It calls the calculator with the right input. It then observes the result, 10.05, and realizes, okay, I'm done. And that becomes the final answer. You're literally watching it reason its way to a solution. So you see, LangChain isn't just about building smarter chatbots. It's providing the fundamental building blocks for autonomous agents that can reason and act. This is a huge leap, and it leaves us with one heck of a question to think about. When AIs can truly reason and act on their own, what are we going to build next?